Hello everyone. So today we'll be continuing our binary search series and we'll be looking at the topic upper bound. So, what exactly is upper bound? So, upper bound is something when we return the smallest index where the array of index is greater than the target. So, what does it mean? Again, we'll understand it with the help of an example. So, here we have given with an array and we have some elements in the array and then we have a target. So now what do we have to return? We have to return the smallest index where the element present at that index is greater than your target element. Okay, so clearly in this particular example our target is 6, so we have returned 3 as an answer. Why? Because the smallest index where the element is greater than the target, which is 7, is present at index 3. Very similar to the lower bound question, yeah, where the condition was slightly different. There the area of index was greater than equal to target. Here it's just greater than target. um, One important thing that I missed in the previous video was to highlight the monotonic structure. Monotonic, what do you say? Monotonic structure of the implementation. So, like the key um, rule of the binary search is that it follows a monotonic pattern. So, as you can see, the condition where array of index is greater than target, it is followed by all these things, all these indices. So 3, 4, 5, 6, 7, 8, 9, all these indices follow this condition. So while reading the question or while understanding the question, we can look for a monotonic pattern. So here what we found was 7 is identifying the condition, 8 is also doing that, again 11 is also doing that, and then 12 is also doing that. So then we thought of a binary search as a solution. So we can always think of it in a monotonic way as well. Look for a pattern and then think whether we can apply binary search or not. Okay, so again, since we are applying since monotonic pattern is being applied, so the answer can also be 9. So what we are looking here is we are saying if nums of mid is greater than target. Here the target was 6, so if any mid comes like at any indices between 3 to 9, we can see if it is greater than the target, we'll just store the answer and restructure our end variable to mid minus 1. And again, if it is less than equal to target, then just restructure the start to mid plus 1. So I guess that is pretty clear about the understanding and the concept of the problem. We'll look at the code and we'll see. So this is the code, exactly the same code as what we implemented in lower bound. The condition just changed from greater than equal to greater than, and less than to less than equal to. Okay, because here we are not considering the element itself, we are considering element greater than the target. Okay, so that is pretty much it. We'll just run it. Answer should be 3, I guess. Yeah, the answer is 3. So upper bound and lower bound, both the sums are very similar to each other with some minor differences. So I hope you guys understood what is upper bound, and I guess that's it for this video. Um, in the next upcoming videos, we'll be solving the first occurrence of an element and the last occurrence of the element using binary search. So we'll be looking, if you want to find the first occurrence in the repetitive elements, then how we can do that. I guess that is it. Thank you so much for watching and see you in the next one. Thank you.